Picture a soldier on a battlefield with a wound so severe it's about to become fatal. In most of the animal kingdom, that's simply the end. Injured means left behind. But about 6 feet underground, one insect colony runs something closer to an actual field hospital, rescuing their wounded and carrying them back home. I used to think instinct in insects meant something rigid and mechanical. The more I looked into how this colony operates, the more that assumption fell apart completely. Meet the Matabele ant, a species found across the dry expanses of sub-Saharan Africa. Their entire way of life revolves around raiding termite nests, and termites do not go down without a fight. The defending soldiers have powerful mandibles built to crush attacking ants, regularly leaving a significant portion of the raiding party with bitten legs and severe damage on the walk home. This constant state of warfare means the colony absorbs mass casualties on a daily basis.
To survive, they had to develop a system to handle the sheer volume of trauma. When a Matabele ant takes a hit, it releases a specific chemical distress signal. This pheromone flare acts as an immediate SOS, prompting healthy nestmates to respond and pick up the injured ant. But the colony evaluates every casualty first. If an ant has lost most of its legs and the damage is deemed unsurvivable, the chemical signals shift. The communication essentially becomes "don't bother," and that severely damaged ant gets left behind. However, if the injury is limited to 1 or 2 legs, the colony commits real resources to extract them, keeping the lightly wounded alive. Human militaries formalize this exact logic, treating the survivable wounded first, during the First World War. Matabele ants have been running a highly optimized version of that same triage system to protect their population for millions of years before anyone in a medical tent thought to name it. For the ants that make the cut and are carried home, treatment begins immediately. Nestmates take turns meticulously licking the wound, sometimes for 40 minutes at a stretch. Their saliva actually acts as a biological antiseptic, depositing potent antimicrobial compounds directly into the exposed tissue to stop an infection from spreading. Researchers found this rapid first aid cuts the mortality rate of infected ants by roughly 90%. This species has essentially evolved its own internal pharmacy, weaponizing chemistry to keep its wounded soldiers alive. A completely different species faces similar threats, but with a major anatomical disadvantage. The Florida Carpenter ant, living across the lush cypress swamps of the southeastern United States, lost the gland that produces that antimicrobial saliva during its evolution. Without a chemical option to fight infection, they reach for something far more drastic: surgery. When a nestmate has an infected wound on their upper leg, the femur, the ants bite through the base until the limb comes off entirely. But if the injury's lower down on the tibia, they never amputate. They meticulously clean it instead. This anatomical diagram shows exactly why they make that distinction. The femur is packed with dense muscle that dictates the circulation of hemolymph, the insect equivalent of blood. This thick muscle density means an injury up high slows the spread of bacteria, buying the 40 minutes needed for a successful amputation. The tibia has far less muscle. Bacteria entering there spreads far too quickly for a slow amputation to help, leaving intensive cleaning as the only viable option. The survival data confirms the strategy. In clinical testing, amputated femur injuries survived at rates around 90 to 95%, and cleaned tibia injuries survived at about 75%. Left completely untreated, survival for those exact same injuries crashed below 40 and 15%. The ants select a precise, context-dependent treatment based on exactly where the damage is located. They are making the same clinical judgment call a human surgeon has to make. 2 distinct lineages on 2 different continents arrived at 2 completely different solutions, chemistry in one case, surgery in the other, to solve the exact same survival problem. Today, human medicine is facing a severe crisis of its own, as bacteria increasingly develop resistance to our standard antibiotics. Because of that, researchers are actively studying the antimicrobial compounds found in ant saliva to see if they might be effective against those resistant human pathogens. It is entirely possible that our next major medical breakthrough traces back to a microscopic system running quietly underground for millions of years. If this challenges how you think about what instinct actually means, let me know down in the comments which part surprised you most: the triage, the saliva, or the amputation.